Okay, guys, here we go. Practice day for probability. I love this sheet that I made up. Way better than the review because I organized it all by topic. So first, let's just take a look where I have the blue highlights. So the first section is going to be and or questions. And all I did was go in and, just put some formulas in ahead of time. The next section is going to be conditional probability. The third section is the independent-dependent questions. The fourth section is multiple events. That's where we more than one thing is happening, and we have with and without replacement. That was day one. And then the last part is complements. Okay, so again, I love this because I organized it all by topic for you. So all I did was go in ahead. Oh, sorry about that. I gave this to my husband to scan for me, and this is like my sheet to get copies, so just ignore that. Okay, now I wrote on here, great practice, study this, really, this is it, okay, it's so important. All right, so let's see what's happening here with and or. Okay, so I gave you just probability of what x is, probability of what y is, and what probability of x and y is, because I want us just to straight up practice using the formula for probability of or. As soon as you see or, you have to think plus minus. That should be like in your brain, plus minus. So here's our formula. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, which is both. So now we're just going to go over and substitute in all of these pieces. So the probability, I learned how to zoom in now. So my daughter showed me that. Now I can write neater. So I can zoom in and write, and then I zoom back out. So the probability of A or B is equal to 0.5 plus 0.3 minus 0.2. So the probability of A or B is equal to 0.6. And that's it. So it's just substituting in. Okay, basic formula. Okay, let's try another one. It says if the probability of A is 3/15, the probability of B is 10/15, and the probability of, okay, so what is this symbol right here? Again, I'm going to zoom in and I could do it neatly. That symbol is and. And the easy way to remember that it's and is because, look, you can turn it into, I don't want to ruin it, but you can turn it into an A. That's how I remember that it's and. Okay, and then the other symbol over the U is or. So I want to find or. So I wrote the or formula again. Everybody see it? Write your formula, and then substitute in your values. Okay, now I'm going to zoom in so I could do it neatly. So the probability of A or B is equal to the probability of A, so 3/15, plus the probability of B, 10/15, minus the probability of both happening. Remember, you got to take off probability of both happening because you're actually counting it twice in the A group and the B group. So the probability, and you can just throw this right into your calculator, of A or B is equal to 11/15. Okay, just throw it right in. You're just looking for those keywords. Okay, number 3. So number 3 is one that's been on the Regents, okay, a couple times. So it says here a biology class has 220 students, 89 are on a sports team, 70 live on campus. If the probability that a student is on a sports team or lives on campus is 115 out of 220, what is the probability that a student does both? Okay, so both is and. Right, both is and right here. Oopsie, where did I go? Okay, oh gosh. Okay, hold on. Did I go down too far? Where did I go? Okay, right there. I just was trying to circle and. Okay. All right, so both is and. So This is why it's so important to take the information out on the side, because if you take the information out on the side, you can see what you have, and then you could think about what formulas could I use. So there's 220 altogether, 89 are on a sports team. So see, I had to make my own fraction over here. So after you make all your info, you can see that you have S, you have C, you have OR, and you want to find AND. So we can actually use the OR formula to find AND by just substituting in the information that we have. Okay, so again, I'll just zoom into copy so it's neat. So it's going to be 115 over 220 equals 89 over 220 plus 70 over 220 minus, and that's what I want to find. So see, I just substituted in everything over here to the side. That's why it's so important to just write it all, because then it shows you what you have and maybe what possibly a formula you could use. So add everybody up, do a little bit of equation solving here. We want to solve for x, so I'll subtract 159 over 220. And now you're left with negative 44, right, over 220 equals negative x, but divide through by a negative. And now your probability of S and C, both things happening, is 44 over 220. Very, very popular question, okay, for you guys to know. All right, so that's my and or section. Now let's go to the conditional section. Remember what the conditional is. The conditional is when I said, if I polled the whole class and I said, raise your hand if you have blonde hair. If I was going to pick one student from the group, right, what's the probability they have blonde hair? So I'd be looking at everybody. But then what if I change the probability to say, raise your hand if you're a girl and you have blonde hair? Now I'm changing the condition. The condition is I'm only looking at girls. So a conditional probability has like a stipulation, like something has to be taking place. But we have a formula for conditional. So here it goes. All right, so I'm giving you information on the left there, just listing it to make it easy. It says calculate the probability of x given y. So here I wrote it out, probability of x given y. But you need to change that. It becomes the probability of x and y. So if I was in class with you, I'd be like, saying like, let's pick out that bar in the middle, put the word and there, and then you always divide through by the second one, so the probability of y. And now you just take your information on the left and sub it in. So the probability of x and y is going to be 7 over 27 divided by 15 over 27, right? Now this just became top-bottom. Keep the top, multiply by the reciprocal of the bottom. And I love this method because this always happens. If that doesn't happen, then you messed up. So the answer is 7 out of 15. Conditional probability. Okay, let's try another one. So the probability of a student at West High School scoring over 1,200 on the SAT is 0.63, so that's 63%. You can see I wrote everything out to the side, so important that you guys come over here and do this. The probability that GPA is over 3.5 is 0.71, that's 71%. And the probability of both is and, is 0.34. Calculate the probability of a student's GPA being over 3.5 given, right, so now I wrote out the formula here, given they scored over 1,200 on the SAT, to the nearest hundredth. Okay, what's the first thing we do? We take out that little given guy and change the formula. The probability of GPA and SAT, and then we divide through by the second piece, probability of SAT. And then we simply just plug in our info. So this is nice. There's no top bottom in this because they made them decimals. So 0.34 divided by 0.63. Just use your calculator. 0.5396 They said nearest hundredth. Hundredth is the second spot. I look one place to the right. If it's 5 or greater, I push it up, 0.54. And that's it. Okay, let's try another conditional. They like to give conditionals with tables. So see here, you needed to add them up, right? Add up going down, going across, get a total. And they're still going to ask me a conditional question again. So it says 400 kids took a test. The table to the right shows the results of who passed and failed, whether they attended the group review or had a tutor. What percent? All right, so now at the end I have to change this to a percent. So decimal 2%, to the nearest tenth of a percent of the students passed, given they had a tutor. So passed, given they had a tutor. So now we change it over again. Probability of passed and tutor divided by the probability always of the second one. Oopsie. Oh gosh. Okay. All right, so we have to go back to our table now. Okay, so probability of passed and tutor. So just take you 2 fingers and find passed and tutor. Isn't this one passed and tutor? So 130. So 130 out of 400 divided by probability of a tutor. So probability of a tutor is 140. 140 out of 400. And then a little top bottom. Keep the top, multiply by the reciprocal of the bottom. Goodbye, and we're left with 130 over 140. Okay, now they wanted us to turn this into a percentage though, so we'll make this into a decimal first, so 0.92857, right? Then we'll turn it into a percentage using this guy. So 92.857, blah, blah, blah. But then it says nearest tenth. So I'm going to come over here. 92.9%. Right? Tenths place is right here. Look one place to the right. If it's 5 or greater, push it up. All right, that's for conditional. Okay, now let's do independent, dependent. So remember, independent and dependent events, do they affect each other? Right? That first question I did with you was salt and pepper, and I think that question came out that they were dependent. Usually, things do call for salt and pepper, but we have to make calculations to see if events really do affect each other or not. Okay, let's see. Okay, so, sorry, I was getting distracted because people are sending messages already, but I'll answer them after. All right, probability of X is 0.72. Probability of Y is 0.45. Find the probability of X given Y. Okay. Sorry, I'm getting so distracted because this phone is going off. I'm trying to see what the messages are for students, but I got to push it away. Okay. Okay, so are these independent or dependent? So remember, we have 2 formulas that we can use to see if something is independent or dependent. We have probability of, let me see where I could write these. Oh, there's no room up there. Okay, I'm just going to write it, and then I'm probably just going to erase it, okay? So these are the 2 formulas we have. I'm going to write them and then erase them. So we have the probability of A given B, and we could set that equal to the probability of A. Remember where it's all the every other, A, B, A. And then you want to get decimals and compare them. And if those 2 decimals come out to be the same, then we know that they're independent. If they come out to be different, then they're dependent. Okay, the other formula we have is the product rule. It's the probability of A and B, oopsie, and we set that equal to the probability of A times the probability of B. And then again, we look at both sides' decimals and see if they're the same. So if I look at these 2 blue formulas, which formula should I use based on what the information that I'm provided over here? We have to use this formula, right? Because they're giving me the given. I can't use the product rule because I don't have and. Okay, so I'm going to erase now and make this neater. Okay, so this is my formula, right? But I have x's and y's here. So the probability of x given y is that equal to the probability of x. Remember, it's every other. So now just substitute in 0.72 equal to 0.72. They're the same. They're the same, therefore independent. Okay, let's try 8. Number 8, I'm going to show you how we can do both ways, because here they're giving me enough information that I can do both ways. So it says, are x and y independent or dependent events? So we will do both methods now here. In number 7, we were kind of forced into having to do it that way. All right, so the conditional way. Yeah, this should say A and B. So just change that over. Okay, so here we go. So I'll start out with probability of A given B, and I'll set that equal to the probability of A. Now, when I use the conditional method on this one, see how the probability of A given B is not up here. So I am going to have to change the formula over to the probability of A and B. So it's just a little bit more work. That's why if you can use the product rule, it's easier. Over the probability of B, and then we set it equal to the probability of A. So we have 0.2 over 0.6 equals 0.3. And now compare the two decimals, divide them out. I get 0.333, right? Is that equal to 0.3? They're not the same. So they're different. Therefore, DD, different, dependent. Okay, so that would be my answer. Remember, we're looking at those decimals. Now let's do the product rule. Now the product rule, I better get the same answer. I better get that they're different. So the product rule is the probability of A times the probability, oopsie, let's fix that. Write the and first. So the probability of A and B is equal to the probability of A times the probability of B. So we have 0.2 equals 0.3 times 0.6. So 0.2, does that equal 0.18? No. So they're different, therefore dependent. So either method that we do, we can see they come out to be dependent. Okay, but the above one, number 7, we couldn't use the product method because they didn't give us and, they gave us just the conditional. Okay, 9 and 10 are a little different. 9 and 10, they're telling me that they're independent events. They're saying, hey, these are independent events. So that means that both of those tests up above that I did are true sentences. So if they're independent events, they're saying, what is the probability of A and B? So that means that the product rule will come out to have the same decimals. So therefore, I can just multiply them and I can find the probability of A and B. So this problem's a little different. So you're just going to multiply these two because this is factual. So the probability of A and B is equal to 14 over 81. Okay, so that's a little different because they're telling you that they're independent. And then this one does the same thing. It tells you that they're independent, right? But now I want to know what's the probability of x given y. Well, that means that the probability of x given y is definitely going to be equal to the probability of x because it's a true sentence. I'm telling you they're independent. So the probability of x given y is equal to 0.8. There's no work. Okay, so those are definitely like different types of questions. Okay, let's do independent, dependent from a chart. Okay, 65 students were surveyed. Are female and not going to college independent events? Okay, so it's your choice now. You can use the product rule, you can use the conditional. It doesn't matter the order you set it up in. So I think what I'm going to do is I'm going to use the product rule because it's definitely easier. Let me just zoom in a little so this gets a little neater. So I'm going to do the probability of female and not going to college. I'm going to try to use the product rule. I'm going to see if that's equal to the product of female times the probability of not going to college. And now just sub in your info. 8 out of 65, and I'll zoom back out and we'll see where this came from. Okay, so the probability of female and not going to college. So female and not going to college, just take your fingers and find it. There it is. Probability of female, just go down to the total female column. And the probability of not going to college, just go to the total not going to college. And then multiply everybody out and compare the decimals. So on the left, we get this guy. On the right, we get this one. And we can clearly see those are not equal. So those are different, therefore dependent. Okay, right from a chart. Okay, one more independent, dependent. Yeah, this one's a little tough. Okay, so it says, given the events A and B, such that the probability of A is equal to 0.4, and the probability of B is equal to 0.8, and the probability of, so this one's or, this symbol, right? Because I remember that this symbol, you can turn it into an A, so that's and, so the U is or. Determine whether or not they're independent or dependent. Now, here's my problem. If I use the conditional, probability of A given B equals probability of A, I have to turn it into the probability of A and B, so I need and. If I use the product rule, probability of A and B is equal to probability of A times probability of B. I need and. So I need and no matter what I do. The only way I can find and is if I use the or formula, and I have or there. So we'll go back to or. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So here's an example of an independent dependent question, but I actually have to use the or formula. So let's go over here. Oops. And let's make that X. Okay, so let's just sub everybody in. So we got 0.88 is equal to 0.4 plus 0.8 minus X. Combine like terms. Move that 1.2 over so I can solve for X. And we get negative 0.32 equals negative X. Divide through by negative 1. And now we got 0.32 is equal to X. But remember what that really is. That's the probability of A and B. Okay, so now you can use whatever rule you want to use. I think I'm going to use the product rule. So the probability of A and B is equal to the probability of A times the probability of B. But you can use conditional if you want to, it's just more work. So 0.32 is equal to 0.4 times 0.8. We get 0.32 is equal to 0.32. So we can say that these are the same, therefore independent. Okay? Okay, last section. I know this is long, but I felt like this was just such a good, oh gosh, such a good sheet for you guys. Okay, last section, last two little sections, multiple events, with and without replacement. When we have multiple events, we multiply the probabilities. All right, let's check it out. A bag contains 4 orange, 2 yellow, and 5 black markers. If 2 markers are selected with replacement, so with replacement means I'm putting it back in the bag before I take a second one, and the denominators won't change. My sample space will remain the same. So what's the probability that both are orange? Well, when I reach in the first time, probability of orange is 4/11. Times multiple events means multiply. I stuck the marker back in, chance of getting orange again is 4/11. Multiply straight across. We get 16 over 121. Now we start over again. If 2 markers are selected without replacement, so now the denominator is going to change the second time. What is the probability that yellow is selected, then black? All right, so yellow is 2 out of 11 times black, 5 out of 10. You didn't replace that first marker. So we get 10 out of 121. Okay, and one more. What's the probability of orange without replacement? All right, so orange the first time is 4 out of 11, but now you kept that orange out, there's only 3 left, and the sample space went down. So 12 out of 121. Okay, last little bit, guys. Oh my gosh, I keep doing that, sorry. That's the pre-calc lesson. Okay, complements. Complements, if there's a 40% chance of rain, there's a 60% chance of no rain. So the formula is the probability of an event plus the probability of non-event equals 1 whole or 100%. So I said the probability of an event occurring is 8/15. What is the probability of the event not occurring? So you're just going to do 1 minus it, and you wind up with 7/15. But what would be like the Regents question you might get, it could be like 15. It says the probability of an event occurring is -2 over x plus 4. So if we want to find the probability of it not occurring, when we do 1 minus this, remember we're going to put this over 1, and we're going to get an LCD. So the LCD is x plus 4. So I'm going to multiply the bottom by x plus 4 and the top by x plus 4. So we're left with x plus 4, right, times 1. And then see this minus minus, doesn't that become plus 2 over x plus 4? So x plus 6 over x plus 4. So a little review question like in that one. Okay, that's it. We made it through. I love that sheet, guys. I'm telling you, that sheet is like golden. It's everything you need to know for probability. Okay, that's it. Hope you guys have a good day.